Hi, I'm Rob Price, and I'm talking to CEOs about AI. Welcome to Futurize.
Hi, my name is Lori Salow Marshall, and I am the founder of a company called the Quantum Links Group. And we help companies bring their deep tech products to market. So we focus on commercialization and what we call translation, right? Taking scientific discovery and enabling it in a commercial market. So I've been in technology my whole career, moved up from early stage telco to SaaS to managed services to AI to agentic to now quantum.
Laurie, it's fantastic to have you on the podcast. Welcome. Um,
Thank you,
and
Rob.
and are you in Seattle today?
I am indeed, and it's beautiful and sunny. And
Fantastic.
so and very cool, I have to say. So we're lucky. It's been awful for you guys. So
Well, it's kind of the reverse over in the UK, so it's 30 degrees plus, and kind of we're in the middle of a drought that kind of seems to never stop. Um, so we had a conversation, and you said we should have a chat about agentic and quantum. And I thought, wow, that's two subjects that are going to challenge everybody, frankly. But should we start with what we mean by those things? So
yeah,
if we're talking about quantum, which we've been talking about in the industry for a while now, what
yeah,
what do we currently mean by quantum? And certainly from a West Coast point of view, what do we mean by quantum?
great, great. So I always think it's good to introduce the concept of quantum in the physics. So there's two physics theories that have been proven that underpin quantum computing. The first is superposition, which means that while we use with classic computing an ordinary bit is a zero or a one, with superposition, it can be both. So superposition means you can kind of be in two places at the same time. You can have two things superimpose upon each other. Entanglement is the second theory, and that is where the theory is that you're linked despite distance. And so qubits, which are, the quantum bits, can be still connected even if they're in different places. So that concept of entanglement actually has kind of a multiplier effect. So when you add these things together, what happens is you have massive parallel processing capability associated with quantum computing. So quantum computing isn't just a really fast computer. It is basically a probabilistic engine that plays out numerous scenarios at one time and then uses inference to take the scenarios that are most likely going to occur and then use those as their outputs. So it's really well suited for highly complex, mathematically challenging situations. So, drug discovery, metamaterials, financial services, those kinds of use cases. The probabilism is a thing that you have to think about in the context of agentic, right? Because if you're doing a workflow, you want that workflow to be more deterministic and repeatable, and you don't want it to be subject to probabilistic natively probabilistic outcomes. So quantum computing isn't just about more processing power. It's about a totally different way of doing computing. And it breaks out into a number of different industries that we can talk about if you want, but it's not simply quantum everywhere. There's quantum sensing, quantum computing, quantum communications, and then post-quantum cryptography, which is not quantum technology, but it supports the quantum space.
And weirdly, kind of that was exactly where I was going to go because
Yeah,
I think it's at least 10 years since I contributed to a white paper on quantum cryptography, because at that point in time we were all thinking about how do we design security and protection around whatever it was in a world that
right.
was quantum. And to your point, there was always this view that said there were certain algorithms or workloads that were going to lend themselves to a quantum capability, and
Yeah.
therefore is that still the case then? Is that pretty much still the case in terms of how we should think about those things. The only difference in the 10 years, 12 years, whatever the time has been, is that there's been more evolution, more innovation, more steps forward in terms of qubits, etc.
So yes, that is the case. I have to say that even in the last 10 years, some of the major physics theories that underpin quantum computing have been proven, and they weren't proven 10 years ago. So quantum is this kind of naturally evolving and still learned science, which is really interesting. And from a quantum computing perspective, being able to apply it to these very complex mathematical situations is definitely still the way that people are thinking about it. So I talked to a couple of people in advance of the podcast. I wanted to bring, not just my ideas, but other people's ideas. So I met with Michael Brett, who is with Amazon Web Services and leads the quantum activity there. And then Josh Moles, who is ex State Department, ex Google, ex IonQ, and then a woman named Ari Yu, who is the leader for the Northwest Quantum Nexus, and she's more on the policy side. And in general, the thinking, so in general, what we're seeing in terms of use cases on the West Coast is that so AWS has their bracket technology, it's up and it's live. And the way it's being used is that it's basically like old, well, they'll probably kill me for saying this, but like old supercomputing model where you take over the computer for a week and you do a set of workloads, and then then you're done. Then the next person comes in and the next person comes in. So right now the main use cases are coming from research and government, so universities and government, um, oftentimes founders, so early stage companies that are looking at building quantum applications, which is still very much in its in its nascence. And then lastly, big banks like the JP Morgan Chases of the world, because they're looking at the financial services implications of it, and they've got obviously massive amounts of data that they can test and run against it. So, and then of course, as we all know, right, the big issue too is the data clean? So the data issue is still a major issue for everyone.
But I guess it also comes back to your point earlier around where you point it. So what's it trying to do? So in a sense, I often talk about ever more powerful models, large language models that people are using, people are focusing
Mhm.
on as being great to solve big meaty problems because in a sense it's that target that compute power to innovate and find answers, which is different from putting it in the midst of a highly regulated space where it has to do reliably the same thing day in, day out, highly auditable,
Right.
proven, etc. I mean, it comes back to your point around probabilistic versus deterministic. I'm kind of intrigued because when we started talking about what's that intersection between AI and quantum, I mean, at heart, I guess we're now talking about a very probabilistic type technology, quantum, with a very probabilistic technology, large language models. Um, what is the intersection? What do you think the relationship could be between quantum and AI in this emergent sense of models rather than machine learning, for example?
So the consensus I'm that I believe and that I'm hearing from everyone else is that AI can help quantum a lot more than quantum can help AI. So right now, when we're looking at how we progress the quantum environment, AI can be applied to exploring quantum use cases and figuring out what use cases would be best to apply quantum computing to. So, what are more mathematically more, if you need to do thousands of scenarios, what are those use cases, and and how are we going to apply those to quantum? The other really interesting thing about quantum is that it will never replace classical computing, right? So classical computing will always be there. LLMs will always be there. In my conversations and what I see, I don't see a route for LLMs to sit on quantum, but that's just today. Who knows about it 3 or 5 years from now? But what happens is that there's going to be an integration between classical and quantum computing, and that's going to be a hybrid environment. Now that has architecturally been broadly developed, and so but there's an opportunity, I think, for AI and LLMs specifically to aid in the development of uh, that integration layer, and also obviously aid in the development of the applications that are going to sit on top of quantum computing. So scenarios, applications, and infrastructure, I think AI will be able to help quantum a great deal.
If people are listening, I mean, maybe it's an age thing. I mean, I'm still sitting here kind of going back to Quantum Leap and watching kind of sci-fi on TV. But if people are sitting listening to the conversation thinking, how do I bring this to reality today in the things that they do? What kind of sectors do you think are going to be I mean, you've touched on a few already, but what kind of sectors should be caring about some of this? And how do they move beyond maybe it being something for thought leadership and discovery to being a tangible difference? What
Right.
will they be doing different today than they would have been doing 10 years ago when, to your point and my point earlier, we were thinking about it rather than doing it?
Right, right. So oil and gas, material science, pharmaceutical and biotechnology, financial services. Those are the big ones. And they're big ones because they're either dealing with massive amounts of data and models, or they're dealing with a lot of different scientific opportunities and outcomes that could be derived. So the other part of this that's in the equation, right, is that quantum isn't cheap. So you really have to know what you're trying to do. You have to have a concept around the return on investment that you're going to, drive from a quantum engagement. So understanding, I think the first step is understanding problems that you can't currently address right now with classical computing. What are kind of the weird, and you could, like I said, you could use LLMs to kind of hypothesize and riff back and forth and say, okay, if I had a quantum computer and I wanted to address something in my known pain points in this space, what are the different scenarios that I could do? And then come up with use cases where you specifically want to solve a problem, and then understand the return on investment against that, and then start to work in developing what you could test in a quantum lab. And so, we're still about 3 years away from fault tolerant enterprise scale quantum computing. So right now it's still mostly lab based, mostly where you go in and you like use a computer for, use a machine for a certain period of time, and then you're off and you're on to the next thing. One of the things that was brought up in the conversations I had with people is that those who get to the quantum computers first, write the papers first, get the patents first, win, right? So there's only going to be so much quantum computing available. So if you have a big problem in your industry and you think that there's something that this massive scenario review opportunity is there to help you, think about it now and define it now, and then apply some quantum pilots to it so that you can determine if there's a there, and then look to see if you can flesh it out, patent it, take thought leadership around it, etc. So I
Does
think
that
that's the
Does that mean it's the usual suspects in terms of the big names again? It's kind of Microsoft, it's kind of AWS, it's Google, maybe OpenAI. Are they the guys who are going, we're going to be first there as well as the whole kind of AI space? Or are there some other parts of the world? Maybe if it's kind of, I don't know, is there ecosystems beyond West Coast US that are kind of equally kind of charging headlong into this?
absolutely. So West Coast US isn't necessarily I mean, Chicago and New York, there are a lot of places in the United States that are actually ahead in terms of pure quantum funding. And then obviously different countries, China is picking up quantum. There are different countries that are taking a leadership position. I think Spain has actually made a mandate around quantum in terms of government. And don't quote me because I might be wrong, but I thought it was Spain. So there are different countries that are actually moving forward and applying a deliberate course of action on this. Um, the IBM has made quantum computing available at very low cost. So there's a lot of opportunity for founders and early stage companies to come in and jump on, and do quantum work with IBM and or AWS, right? So I don't think the cost is an inhibitor in terms of getting something out there. So it doesn't have to be the big guys in terms of the cost. I think the founders and the early stage companies that are imagining what could be done, they're going to take advantage of this time as well. But I do think that for a lot of the use cases, it's going to trend towards the large enterprises, the verticals that I talked about. In terms of like horizontal plays with like an LLM company or something like that, I haven't seen anything that indicates that they're, aside from being a provider, that there's a quantum play in what they're doing, but that doesn't mean that that's not the case.
I guess logically, I mean, as you were talking earlier, I was thinking as we begin to see more and more recursive AI, then an overlay of recursive AI, don't know what the right word is, powered by quantum, but I don't mean compute power. I mean an overlay of that algorithmic kind of capability. Then logically, that should that not be an accelerant in the sense of if the power of the both capability for certain problems, for certain use cases, should kind of drive some interesting results or not.
As of now, I interviewed people and they said not. So, because they're fundamentally different because of they're not multipliers of each other. They're fundamentally different. So um so as I said, the inputs on large language models, the development around quantum using large language models and agents to do the development work, those are all things that are going to be really valuable. But in terms of just applying quantum computing behind LLMs to make them more powerful, that is not something that
I
people are
think
supporting right now.
I think I was trying to explore more of the recursive element, so less about the degree of power behind it and more
Okay,
around its ability. I mean, it comes back to if you've got a probabilistic algorithmic innovation capability,
right.
then the combination of two of those logically should kind of create more innovation,
Or
stroke chaos
right, right.
than one in isolation. But I think, I mean, let's bring it back to this is a space that kind of you've thrown yourself into, and I'm guessing that
That's a good
there's
way to describe it.
and there must have been a reason for that, as opposed to so from your point of view, you must see this as interesting, exciting, challenging, because I know you well enough to know that you'll have been drawn to it for a reason.
Yeah.
Tell us a bit more
So
about that.
so I am on a quantum physics quest in general. So I look at quantum physics in three buckets. So one is the actual physics of it. And I started this Substack called Ecosystem Entanglement, where I'm using the principles of quantum physics to describe business scenarios, right? And so it's a bit of fun. It's really not meant to be, anything crazy. And let's face it, it's a bit of fun for like, 1% of the population who's nerdy enough to really think that this is fun. So that's the first thing. So the quantum physics side of it, there are like, you know, 10, 12, whatever the number of principles that are really drive quantum physics, and understanding each of those principles and understanding the history behind them and understanding the recent history, because a lot of it is relatively new, is fascinating. So I think that in terms of understanding our world and understanding the science of our world, you and I grew up when, Pluto was a planet. It's not now. Um, Quantum physics is continually evolving. So getting smart on what it is and where it's going and what's been learned and what those core foundational principles are is really interesting to me. The second thing is then, how do you take those principles and apply them to the technology? And that's where quantum sensing, quantum computing, quantum communications comes into play. Quantum sensing is super interesting, right? When you look at things like GPS denials and and where we're going in terms of what time will mean in terms of AI infrastructure and the requirement for time to be down to the nanosecond and picosecond level for agents to work correctly in financial services and a lot of other places. Um, Current time infrastructure around the world is not really able to live up to the requirements of the AI infrastructure world. So quantum sensing will inform that, and then there'll be delivery mechanisms to support that. I'm working with a company in the United States that's doing that in the US, and it's absolutely fascinating. And then the third part of it is woo-woo, quantum consciousness. So how does, how does quantum physics affect what we believe in terms of like the afterlife and energy and spirituality and our connectedness as a species and all of this kind of stuff. So I'm enjoying that as well. So that's my yeah, I have steeped myself in it.
And how is the, I mean, if we look across Seattle and the broader down the West Coast, how does the ecosystem of startups and scale-ups around quantum use cases or applications compare with, for example, AI and agentic? Is it seen as something, is everyone as mad for that, or is there a degree of, well, we've been talking about it for 10 to 15 years, so we're still interested, but we're also kind of conscious that it hasn't yet triggered the expansion that maybe we've seen over the last kind of 2 years with AI.
So answer the question in two ways. So first off, I think that the ubiquity of AI and the ubiquity of things like cloud computing and technologies like that will never be quantum, right? Quantum's always going to be a little bit nichey, always going to be specific use cases, always going to have to have kind of an ROI around it that's going to make sense for what you're doing. So that naturally kind of the universal applicability of it is different. So that's one part of it. The second part of it is I find the quantum community to be really interesting. These are people that are actively, I mean, sort of the AI community is too, obviously, but it's just much bigger. It's much bigger. The quantum community is still relatively small, and it's a group of people that are, really committed to kind of learning this and bringing it forward and educating. When you talk about category creation and marketing, I mean, this is the classic category creation challenge, right? Nobody really knows where this is going to go and how it's going to go. But there are so many pilots out there. There's so much actual work that's being done that there isn't any frustration with timing or where we were 10 years ago versus where we are now. There's a lot of good work that's being done. And then there is the whole post quantum cryptography issue too, which is not quantum technology, but it's related to quantum. And so that market is taking off, and the quantum sensing market is taking off. There's real technology in place. There's atomic clocks in place, so quantum sensing is actually live and well and dry and moving forward pretty aggressively.
So in essence, if we go back to what's the relationship between AI or agentic AI and quantum, then I think we're summarizing it in the sense of AI can absolutely help advance that scientific exploration in the same way that it can around new materials or it can do around pharmaceuticals and drugs and solving disease, etc. So the exploration piece of AI can absolutely help accelerate that pathway and journey.
Yeah.
But if somebody's kind of trying to work out how they kind of run their agents faster or more reliably, or get some agents to talk to other agents kind of across kind of different applications, then they're not kind of particularly useful to kind of get sidelined by quantum, because that comes back to that's the agentic layer control plane, or whatever phrase you want to use within that enterprise organization, and as a different solution. Is that fair?
Yeah, that's totally correct. And one of the interviewees used chaos as a response to that scenario that you just played out.
But in a sense, that's why we do the podcast, because it's kind of exploring
Exactly.
how do organizations drive some degree of control and governance and risk management in the same way that we've had to for the past kind of decades as well. So, irrespective of well, I called it playground earlier. Irrespective of kind
Right.
of the importance of people to play in that playground, you still need to kind of make sure that you don't get sacked because you're not compliant with the necessary governance frameworks or regulations or
Right.
law that dictates kind of how you should act. Of course, that's
And
why many of us do what we do.
well, and to your point, Rob, like it also doesn't mean that you won't come out with with an incredible use case that materially changes your industry that can be applied to agents for execution. So, there's a life cycle element of this that can be explored that I think is valid. It's just that in the actual processing, they aren't attached to each other.
Maybe it's almost as though what we're trying to do in the agentic space, and this is hugely unfair, and I apologize to anyone listening, is solve the boring. I.e., how can we sustain organizations doing the things that they need to do in a world that's having to deal with things like aging and sustainability and various other things? How can we do it more efficiently, driving productivity, reduce elapsed time to deliver? I guess there's probably not many quantum scientists who are going to get excited by those things in an enterprise workspace. But at the same time, obviously, there's some big problems that the planet needs to solve and the people on the planet needs to solve. If you're
Yeah.
looking at it at that level of how do we solve climate change? How do we solve hunger? How do we explore space and beyond? Am I being too sci-fi in terms of thinking of it in that way? What are the big problems that I mean, I know we've talked about some of the sectors and kind of the applicability, but from your point of view, if you were to kind of look at you diving into this sector to for the reasons that you've described, in the next 5 years, what are the problems that you would hope have moved forward? The
Yeah.
planet has enabled them to be moved forward by the continued advance in quantum.
Um, so so quantum is inherently less requiring of power than classical computing and LLMs. And so uh the footprint that quantum is going to add to our climate change situation is relatively smaller in comparison to the other computing situations. I just wanted to throw that out there. But I think that climate change is obviously, I would put that as one of the top ones that we could look at. And I think that at the end of the day, the I don't think it's boring, the agentic potential, and because if we can discover what we need to do and then apply it at speed, and with rigor and discipline, and understand that what we're doing is not prone to human fallacy. I mean, at the end of the day, I think that's a pretty exciting outcome. So yeah, so I think that climate change is probably the number one, and then obviously looking at cancer treatments is a very big thing, and then Alzheimer's, dementia, all of the big troublesome situations that medical conditions that have stumped scientists for years.
And I think in many ways, I mean that's all tangible. I mean, people feel that every day, don't they? I mean, kind of
Exactly.
my daughter is running for Alzheimer's to raise money for charity. I've ran for a variety of similar causes in the past. So they're meaningful for people, perhaps in a way that more so than an agentic workflow kind of doing something a bit faster in a business is. I mean, it's relevant for the people in that business, but not
Right,
humanity, if you like. So,
right,
so is that what we're saying in the sense that some of those changes enable those biggest problems to be solved? The other thing that I remembered, I had a chat once with a guy on the podcast, a brilliant guy called Sada Shankar from Stanford. And he made this comment around we've got a long way to go because the efficiency of the human brain to process kind of things versus a data center that got very hot and kind of therefore required loads of cooling. I mean, the
right, right,
efficiency of the brain versus like bio
right,
kind of
right, 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 right,
material
exactly.
was a huge difference. So, and I think when I've heard people talk about the numbers of data centers that we need to get built and the time it takes to kind of build them, there's always that kind of thought about, well, what will we need at the time that they're there? Because it may not
Right,
be that.
right,
But equally, you said earlier that quantum does not replace compute power. They're
right,
different things.
right.
So we need both.
Right. So I mean, it won't replace all of it, but it'll complement. And then, obviously the things that quantum is addressing are heavy compute issues, but they'll be doing it at a fraction of the energy utilization that classical computing would. I mean, space is another thing, right? So I mean, I am very interested in the data center and space story and whether or not that's something that we can do without, damaging another, you know, environment. So quantum can help a lot on the space front as well.
And I will always remember a very good friend, no longer with us, unfortunately, who proposed data centers at the Lagrange points in space because of all sorts of variety of reasons. And that was at least 15 years ago that he was talking about that. So completely agree. And of course, people are doing kind of things of that nature today as we speak. So I think there's a really key message throughout all of this conversation, which is something along the lines of, I mean, even if we kind of forget the quantum piece for a moment, I often talk about the continued focus around model power and development as geared towards those environments where you're looking for probabilistic innovation and solving of big meaty problems. They are geared towards
Right.
discovery, new ideas, new concepts, acceleration. Um, and my slightly biased, I admit, personal view has been that you need some sort of wrap around that or risk governance layer to apply that within the enterprise space to do useful enterprise work artifacts, work products, etc. They're two different things. What I'm hearing from this conversation is that quantum is firmly also of huge relevance in the first. So discovery, solutions, solve those big meaty problems, keep us going from a planetary sustainability point of view. But if you're sat in the typical enterprise workspace, trying to decide what you need to focus on, probably better looking at agentic and AI at the moment rather than kind of worrying too much around what's happening in the world of quantum. Am I being unfair?
You're 1,000% right.
Cool. Laurie, I knew it would be a kind of fascinating conversation, kind of explore some things that admittedly not everyone is going to be at the heart of. Many thanks for coming and talking about quantum and agentic on the podcast.
It was wonderful to be with you, Rob. Thank you so much.
Thank you.